Hi Pre-Calc, we're going to do a couple examples from 6.4 today. This first one says, find the rectangular coordinates of the point 2, 7 pi over 6. What we know is that the radius is 2, and the angle is 7 pi over 6. We are looking for rectangular coordinates, so x, y, and we can find this pretty easily because we know that x is equal to r times cosine of theta, or in this case, 2 times cosine of 7 pi over 6. We also know y is r times sine of theta, or 2 times sine of 7 pi over 6. This would be a problem that you could do with a calculator, but we could also very much do it using the unit circle. So if we think about where 7 pi over 6 is, 7 pi over 6 would be down here. This point down here, we've got similar to our first one up here, which would be square root of 3 over 2, 1/2. So we know down here is negative square root of 3 over 2, negative 1/2. That means we have 2 times sine is y and the cosine is x, negative square root of 3 over 2, and 2 times negative 1/2 to get negative square root of 3, negative 1 as our final answer. Probably not a bad idea to take a moment to see if that makes sense if you plotted it. Negative square root of 3, negative 2, I know is going to be in quadrant 3 somewhere. 7 pi over 6, we know is in quadrant 3 with a radius of 2. That checks out. For this next one, we are given the rectangular coordinates. We are given x, y, and we want to find r theta. However, for this one, we're asked to find more than one answer. The first thing we're going to try, or we're going to start with, is that x squared plus y squared is equal to r squared. Negative 1 squared plus 1 squared is r squared. That means 2 is r squared, or r is either positive or negative square root of 2. Now we can use either of these. I'm going to start with the positive one, and we'll go from there. Now we can solve our equations that we used earlier for x and y. So x is equal to r times cosine of theta. That means negative 1 is equal to square root of 2 times cosine of theta. When I move the square root of 2 to the other side, we would have negative 1 over the square root of 2, or rationalizing, negative square root of 2 over 2 is equal to cosine of theta. Where is this true? But we could also use our sine value, 1, or I guess I could take a step back and say our y value. Y is equal to r times sine of theta. In this case, 1 is equal to square root of 2 times sine of theta. Again, rationalizing in that step, we're getting this. So now the question is, where are sine and cosine both square root of 2 over 2, but the sine is positive and the cosine is negative? That would be, think about it for a second, at 3 pi over 4. Which means one possible answer here is square root of 2 as the radius, 3 pi over 4. Again, it might not be a bad idea to think about where this point is. It's in quadrant 2, negative 1, positive 1. 3 pi over 2, or excuse me, 3 pi over 4 is in quadrant 2 as well. So this would be a correct answer. Now to find the others, you're going to use the things that we did in class. So adding or subtracting a 2 pi, or making the radius negative and adding pi. So there's a lot of different options here. I'm just going to list a few. Negative square root of 2, negative pi over 4. Negative square root of 2, positive 7 pi over 4. Square root of 2, 11 pi over 4. Square root of 2, negative 5 pi over 4. There's really an infinite amount of answers. Next up, we're going to convert this polar equation into rectangular. R is equal to -2 cosecant of theta. And the first thing I will note is that if I see cosecant, I actually am thinking, oh, that's really 1 over sine. So I have R is equal to -2 over sine of theta. It might be something to notice that if I multiply both sides by sine, I get R times sine of theta is equal to -2, and this sine is y is the y. Y is equal to -2 is our equation. However, it's very possible you could have thought about this in a different way. So I want to show you one other method. We again know that R times sine of theta is y, or that sine of theta is equal to y over r. So when we got to this point, that r is equal to -2 over sine of theta, you could have thought, I'm going to plug in this. R is equal to -2 over y over r, which we need to kind of simplify. If we're dividing by a fraction, I'm really multiplying by the reciprocal, -2 times r over y. If I am trying to get rid of r, I would do a couple things. I'm going to multiply both sides by y because I don't really like that in the denominator. So we have yr is equal to -2r, and then I'm going to divide both sides by r. And I get y is equal to -2. Again, the same answer we saw, just a different way to do it. The other question we are asked here is not only to find the rectangular form, but identify the graph. Y equals -2 is a horizontal line. We are going to keep this problem for class on Thursday, I believe. And if you have questions on the other two, see if there's someone in your class who can help you out. Otherwise, we will talk when I am back.